Topic 6-5. This is a review of quadrilaterals. You can reference this in your Holt textbook, Chapter 6, Sections 2 through 6, page 391 through 435. Again, I want to make note of the website. You can Google mathisfun.com. You can go to Interactive Quadrilaterals in the Geometry section and look at all the different types of special properties of the different quadrilaterals. Okay, let's start with an example where we have a quadrilateral ABCD, and we're going to find the different things they're asking in each section. If you've got AD is equal to 10, then BC is also equal to 10 because opposite sides are congruent. If AC is 15, then AX would be half of that, 7.5. Be careful on what they're asking for and which ones, which segments. If the measure of CDA is 111, we've got CDA. They're talking about this one right here. If that measures 111, then the measure of ABC, opposite angles are congruent, is also the measure of 111. If DAB is 69, that's this one here, 69 plus 111 would get us to 180. So 111 plus the 69 added together is going to give you 180 degrees, supplementary. Alright, let's look at some other examples. If we were going to find the values for X, Y, and Z separately for each one of these parallelograms. First of all, let's look at A. A, you're going to look at the opposite one, Y. If this is 58, then this is also 58. You know that 180 minus the 58 is going to give you the consecutive sides. This one is congruent to the one opposite it, but consecutive with these two have to equal 180. So that would be 122 degrees. Alright, looking at B. If this is 32, then we know that Y is also 32. Because two parallel lines cut by a transversal, alternate interior angles are 32 degrees. If this is 98, we add 98 and 32, and we get 130. So 50 more would give us our value here, and therefore alternate interior angles, this one would be 50. Because 50, 32, 98, all added together is going to give you 180 degrees. So think carefully and look at that. It's kind of like working puzzles. And of course, Z is 98 opposite angles. Okay, the last one over here, C. The first one to look at, let's see. If you add 64 and 43, you would get, well, that would just give us that whole measure. Let's see, what they do first. The 106. Well, if this is 106, vertical angle is going to give this to be 106. Adding up, remember how sometimes I'll highlight the whole triangle. This triangle right here all adds up to be 180 degrees. So if we're trying to get 180 degrees out of this entire angle measures, then if you add 106 and 43 to get 149 and subtract that from 180, you'll get the 31 degrees. But you know they needed to go ahead and put degree measures for all of these. These are all degrees. Alright, so if we know X, then we know Z, alternate interior angles. If you think of this being the transversal of two parallel lines, a lot of times I would highlight the transversal. That's parallel to that. So z jumps over the transversal, and z and x would actually be congruent to each other. So they're both 31 degrees. Y, therefore, is 64, same reason. If this becomes the transversal, 64 is going to be congruent to y, congruent to z. Alternate interior angles would be your reason for that. Alright, this last one down here. Find the value of x and y that guarantee that this is a quadrilateral. Well, if it is a quadrilateral, opposite sides are congruent. So for opposite angles, not and opposite sides, but this one they've given you the angles. So these angles show congruency, so that if we solve for x, it's 14. If you plug 14 in and multiply that by 4, 14 times 4, that's going to give you the measure of this angle, which is 56. It would definitely, you've added that and checked it. That would be 56. Well, we know that 56 subtract from 180. If you subtract 56, you're going to get 124. We might want to note that somewhere. You've got 180 minus the 56 gives us the 124. Why? Because this angle and this angle are same side interiors, with this being the transversal, also known as consecutive angles. And then those would equal, this would have to equal 124, because 124 and 56 is 180. So set that equal and solve, and you would get y is 36. Okay, example 4. The rectangle PS, so PS is just halfway through, is that, and GI, the whole line, is 28. These are a little tricky because you have to know that you're taking 2 of your PS measurements. So 2 of your 6x minus 4. Make sure you remember to do the distribution. This times this and this times this. That's where they got the 12x minus 8. And then solved for x is 3. Example 5. In this rhombus, the measure of angle 3 is given to you here as 6x plus 16, just this measurement right there, and the measure of 4 was given to you as 8x. Find x. Well, the diagonals always bisect each other if this was told to you to be a rhombus, so set them equal to each other and solve. Show your work, and this answer would be solving for x is 8. Example 6. If QUAD is a square, find the value of x. Well, measure of QSU. They're telling you that this measure of this angle is 10x minus 5. Well, we've learned that in a square, this is actually a right angle. So instead of making it a curved line, make it a box. We know actually you could make a box all the way around through the whole middle parts of the diagonals, because they would all form right angles. So that's where this 90 comes in. The 10x minus 5 set equal to 90, solve, and you would get 9.5. Okay, remembering the median formula for the very last example here is that this trapezoid with a median of 13 is adding these two together and dividing by 2. So they just took this whole thing, combined like terms, divided it in half. Actually, here they didn't show it. What they did here is combine like terms, but then they multiplied by 2 on both sides. That got rid of the 2's on this side and left what's in the numerator. And then 13 times 2 is where this 26 came from. Solving by adding 2 to both sides and dividing by 7, you get x equals 4. And that concludes Unit 6 with Unit 6-5.